Today we will be talking about OOD and FDD. It will be a light presentation with a small amount of code because I decided to give you the overall picture in just graphs and maybe diagrams to show you my reasoning on how I do it on the higher level of software design, right? So we will talk about FDD from the bird AES view. Okay, is it like a must to have some methodology, and why do we have OOD, and why I state that we didn't have anything equal in FDD, in functional programming? Yeah, I think we need those methodologies just because they show you like a way to do things, and you don't have to be completely in line with those methodologies. You can ignore them completely if you want to and build it as you wish. Yet they help developers to be more conscious, to be more engineers, right? So what is OOD? I think there is no strict definition of OOD. We can refer to Wikipedia, we can refer to experts and other resources, and I guess everyone is defining OOD differently. Yet it helps software engineers to build software because they can have some common ground to discuss their decisions, right? And how this happened, how this is going. Well, when I'm talking about high-level solutions in my career, I can say that there are some philosophies and methodologies to build software. You might have heard about many of them. Here I present OOD and DDD. DDD is domain-driven design, right? And TDD is test-driven development, and BDD may be behavior-driven something. I don't remember what is the last D here. And there are some general principles, and those general principles help us to go in the right directions when we take different high-level solutions. We can evaluate our solutions. Are they good enough? Do they comply with principles, and etc. And of course there are different implementation details. I would say that the upper three levels can be language agnostic, language independent, they can be portable, and the last one, implementation details, well, often it depends on on a specific language. For example, C# or maybe C++, they have different implementations for OOP concepts. C# has interface keyword, C++ doesn't have such a keyword, right? Yet there is OOP there and here, so we use those concepts to reason about our architecture and design. And you probably, I guess most of you are familiar with Gang of War book, like Design Patterns, all right, a very famous book, and it's initially written in C++, like all the samples are in C++, all the design patterns are presented in diagrams and in C++ code, yet it's quite portable, and Java developers took this book and made a Bible from this book, right? Kind of. But what happens when I'm talking about these things in FP, like in Haskell? I feel that not everything is organized into a good shape, into a good knowledge system, and I failed to find any systematic approach in Haskell. There were different takes on this or that. There were different high-level solutions, yeah, a lot of them, but nothing that connects all the things together. And moreover, it was like a feeling that Haskell was avoiding mainstream practices quite a lot. We were in some isolation from the mainstream practices and mainstream ideas, and who knows how to apply TDD in Haskell. Well, today I guess we have a lot of resources, like all scattered across the internet, and maybe a couple of books, but my proposition is not enough. And I would say that we can move some methodologies a bit lower under the general methodology, like OOD or FDD, and domain-driven design and test-driven development both can be applied to any paradigm, and it's quite good to have them described for this paradigm, how to do things, right? How to make your application testable and how to follow TDD. Maybe not its purest form. It's not necessarily to follow the algorithm of TDD, right? Maybe you can just do kind of TDD and DDD, how to transfer this knowledge from the book by Evans to different paradigms. This should be all should be organized into a complete system of knowledge, into a software engineering discipline in particular, I guess. And I think software engineering discipline starts here with a systematic approach. And you can see I've separated some bits here because in FP we have a lot of things that are currently under development. For example, advanced things on the type system. It's not necessarily about FP because it's another paradigm, typed development. And maybe we can have this picture, OP, FP, and type level programming. And I'm doing research in the last one as well. I'm writing another book in parallel with functional design and architecture, and that book is called Pragmatic Type Level Design. And I want to build another complete picture, another complete view of software engineering with that paradigm, because type level programming is a separate paradigm. What do we have in particular in those points? Well, we know that all object-oriented programming recommends to use a lot of principles like GRASP, general responsibility and something principles, and in particular low coupling, high cohesion, a very important principle, inversion of control, right, and the related idea dependency injection, and solid principles, quite important in OOP, and there are a couple of other principles that are coming with functional programming, yet they are well applicable to anything else. I think those principles can be applied to different paradigms, maybe with more or less success, right? For example, GRASP principles are quite OOP oriented. They don't have that much to do with FP, maybe, but high coupling, low cohesion is a good principle that you can apply everywhere. Inversion of control is a very important principle. It can be and should be applied in FP, and moreover, I think IOC is embedded naturally into FP, because we do this all the time when we use first order and high order functions. Solid principles, at first glance, they could be seen as OOP principles, but I'm pretty sure they are more than that. They are more general, and even Bob Martin, who is coined this term, tweeted that solid principles can be applied to FP, and I agree with him. Solid principles are very important, and it's very interesting that they could be organized into this very noticeable acronym, right? Modularity is a very important principle. I think everyone will agree. And purity and declarativity can be mostly applied to FP, but I've been doing pure declarative domain-specific languages in C++ quite a lot in my past career. And yeah, you can see a couple of high-level solutions here. OOP interfaces as a very important tool, rich and anemic models, OOP design patterns, right? And here we probably must have FP interfaces. And what is FP interfaces as a counterpart to OOP interfaces? This is a super important question, and this is where software engineering starts. This is where we can draw a line between software engineering as a practical discipline and everything else around. Domain-specific languages, they are usable in both paradigms, yet in FP we do domain-specific languages all the time, even if we don't know about that, because we want to focus on some domain when building our pure and impure worlds. FP design patterns and FP idioms. I'll tell you the difference between patterns and idioms a little bit later.